Right now, above your head, there are more stars than there are grains of sand on every beach on planet Earth combined. Hundreds of billions of them just in our own galaxy, and hundreds of billions of galaxies beyond that. We now know that most of those stars have planets. Billions of those planets sit in the comfortable zone where liquid water can exist, where life, as we understand it, could take hold. The universe has been around for nearly 14 billion years, more than enough time for civilizations to rise, spread, and fill the galaxy many times over. By every calculation we can make, space should be loud. It should be crowded. It should be teeming with signals, with ships, with the fingerprints of 1,000 alien empires. And yet, when we point our most powerful instruments at the sky and listen, we hear one thing: silence. Total, absolute, deafening silence. This is one of the most disturbing mysteries in all of science, and it has a name. It's called the Fermi Paradox, and it has haunted the greatest minds on Earth for over 70 years. So someone finally did something different. They took this question, the one that has kept astronomers awake at night for generations, and they put it directly to Grok AI. They asked it plainly: if the universe should be full of life, why has no one ever contacted us? What the AI came back with wasn't a comforting bedtime story about friendly aliens. It was a chain of cold, ruthless logic that led somewhere no one wanted to go. And when you follow that logic all the way to the end, it doesn't just answer the question. It forces you to confront something terrifying about our own future. If you want the truth about our place in the cosmos, stay with me and hit that subscribe button, because we are about to walk straight into the abyss. Let's start at the beginning. The whole mystery traces back to a single offhand comment made over lunch in 1950. A physicist named Enrico Fermi, one of the architects of the atomic age, was chatting with colleagues about flying saucers and the possibility of alien life. And in the middle of the casual conversation, he blurted out a question so simple and so devastating that it's echoed through science ever since. Where is everybody? Think about what he meant. Our galaxy is unimaginably old. If even one civilization had emerged millions of years before us and had the urge to explore, they could have spread from star to star and colonized the entire galaxy in just a few million years. That sounds like a long time, but compared to the age of the galaxy, it's the blink of an eye. So if intelligent life is even remotely common, the evidence should be everywhere. The galaxy should already be settled. We should be surrounded. Instead, we look out and find nothing looking back. That gap between what should be there and what actually is there is the paradox. And it only got sharper as our science improved. Just over a decade later, an astronomer named Frank Drake tried to put actual numbers to the problem. He created a now famous equation, a way of estimating how many communicating civilizations might exist in our galaxy right now. You start with the rate of star formation, multiply by the fraction of stars with planets, then the number of planets that could support life, then the fraction where life actually begins, then where it becomes intelligent, then where it develops technology we could detect, and finally, how long those civilizations survive. Plug in reasonable numbers and you get an answer that suggests we should have thousands, maybe millions of galactic neighbors. And here's the crushing part: we've been listening. Since the 1960s, scientists have been scanning the skies for any artificial signal, any whisper of technology from another world. Decades of searching. And in all that time, we found essentially nothing. One tantalizing, unexplained blip back in 1977, a signal so strong and strange that the astronomer who spotted it scrawled the word "wow" beside it on the printout. But it never repeated. It was never explained. And after that, the silence closed back in. So the numbers say the galaxy should be full. The sky says it's empty. Something has to give. And that contradiction is exactly what was fed into Grok. Now, here's what made the AI's response so unsettling. It didn't panic and reach for the easy cinematic answer. It didn't say the aliens are here and the government is hiding them. It approached the question the way a cold logician would, by lining up every possible explanation and asking which ones actually survive scrutiny. And one by one, it worked through them. The first and gentlest possibility is simply that space is monstrously, incomprehensibly big, and we have barely started looking. The distances between stars are so vast that even light, the fastest thing in existence, takes years to cross them. A radio signal fades and weakens as it travels, until it dissolves into background noise. And remember, we've only been capable of listening for a few decades, on a tiny sliver of possible frequencies, pointed at a tiny fraction of the sky. Expecting to have found aliens already might be like scooping a single glass of water from the ocean, finding no fish in it, and declaring the sea empty. It's possible they're out there, chattering away, and we simply haven't tuned to the right station yet. That's the hopeful answer. But the AI didn't stop there, because that answer alone doesn't fully explain the paradox, and the next possibilities get darker. The second possibility is more humbling. Maybe they're out there, but we wouldn't even recognize them if we saw them. We tend to imagine aliens as slightly different versions of ourselves, broadcasting radio waves and flying rockets, because that's the only kind of intelligence we've ever known. But a civilization, even a few thousand years ahead of us, might have abandoned radio entirely, the way we've largely moved past sending smoke signals. Their communication might run on physics we haven't discovered. Their technology might be so advanced it's indistinguishable from nature itself, hidden in plain sight. We could be swimming in evidence of alien intelligence and be as blind to it as an ant is blind to the highway it's crawling across. Our instruments, our assumptions, our entire frame of reference might be far too primitive to detect minds that operate on a completely different level. It's a strange kind of loneliness, the idea that the neighbors might be everywhere, and we're simply not equipped to perceive them. Then the AI moved to a colder possibility, one that a lot of serious scientists take very seriously. What if life itself, especially complex, intelligent life, is just astronomically rare? This is known as the rare Earth idea, and once you understand it, the silence starts to make a chilling kind of sense. We take our existence for granted, but look at how many things had to go exactly right for us to be here. Earth sits in the narrow habitable zone, not too hot, not too cold. We have a large moon that stabilizes our planet's tilt and keeps our climate steady. We have a molten core generating a magnetic field that shields us from radiation that would otherwise strip our atmosphere away. We have a giant planet, Jupiter, acting like a cosmic bodyguard, sweeping up asteroids and comets that might otherwise have wiped us out. We have plate tectonics, recycling nutrients, and regulating our climate over billions of years. Change any one of these factors, and complex life might never have gotten off the ground. When you stack all these coincidences on top of each other, the odds of any single planet threading every needle start to look vanishingly small. Maybe simple microbial life is common across the cosmos, but the leap from pond scum to a creature that can build a telescope and ask where everyone is, that leap might be so improbable that it's only happened once in this entire corner of the universe, us. And there's a sobering wrinkle inside that hopeful answer, one the AI didn't let slip past. Even if the galaxy did contain other technological civilizations, the window in which any two of them could actually notice each other is heartbreakingly narrow. Think about our own story. Humans have existed for hundreds of thousands of years, but we've only been broadcasting radio for about a century, and we may move past detectable transmissions within another century or two. That's a flicker, a candle lit for a moment in a night that lasts billions of years. For two civilizations to make contact, their flickers have to overlap in both time and space, across a galaxy that is 100,000 light years wide. Two candles lit for an instant on opposite sides of a vast dark hall, both hoping to catch the other's glow before it burns out. When you frame it that way, the miracle isn't that we haven't heard from anyone. The miracle would be if we ever did. The silence might not mean no one is there. It might mean that everyone is simply out of sync, each civilization rising and falling in its own brief moment, never quite lined up with another. Every so often, though, something drifts through our solar system that reignites the whole question overnight. A few years ago, astronomers spotted an object from beyond our star system tumbling past the sun, the first confirmed visitor we'd ever caught from interstellar space. It had a strange, elongated shape and an odd way of moving, and for a brief, electric moment, a handful of respected scientists dared to ask out loud whether it could be something more than a rock. In the end, the evidence pointed to a natural object, an ordinary chunk of another solar system passing through on a lonely trajectory. But the frenzy it caused revealed something about us. We are desperate for company. We scan every anomaly, every unexplained flicker, every strange signal, hungry for any sign that we are not alone in the dark. And the AI folded that hunger into its reasoning, too, because it hints at why this question grips us so tightly. We don't just want to know the answer. We need it. Our entire sense of our place in the universe hangs on it. But the AI kept going, and this is where the reasoning turned genuinely eerie. Because there's a family of explanations that assume the aliens are out there, they know we exist, and they are choosing not to contact us. One version is called the zoo hypothesis. The idea is that a sufficiently advanced civilization might be watching us the way we watch animals in a nature preserve, deliberately staying hidden, observing without interfering, letting us develop on our own until we're ready. Under this view, the silence isn't an accident, it's a policy. We're being quarantined, protected, studied, kept in the dark on purpose. It's an unsettling thought that the emptiness we perceive might be a carefully maintained illusion, a one-way mirror with something patient standing on the other side. But even that isn't the darkest door the AI opened. The darkest one has a name that has spread far beyond science, popularized by a famous work of fiction and taken seriously in whispered conversations ever since. It's called the Dark Forest. Imagine the universe not as an empty void, but as a vast, silent forest at night. And in that forest, every civilization is a hunter, moving carefully, listening in the dark. In this forest, you cannot know the intentions of any other hunter you might encounter. You cannot know if they're peaceful or hostile, and by the time you find out, it might be too late. Because technology grows exponentially, a civilization that seems harmless today could become an existential threat in a cosmic instant. So in a universe where you can never be sure, where the cost of guessing wrong is total annihilation, the only safe move is to stay absolutely silent. And if you ever detect another civilization announcing itself, broadcasting its location into the void, the safest thing to do, the logical thing to do, is to eliminate it before it can become a danger to you. Under the dark forest idea, the reason the universe is silent is horrifyingly simple. Everyone who is still alive has learned to stay quiet. The ones who broadcast, the ones who called out into the dark hoping for a friendly reply, were the first to be found and the first to be destroyed. And we, on this small blue planet, have spent the last century doing the one thing this logic says you must never do. We've been shouting into the forest. This is where a lot of people start to feel genuinely uneasy, because it reframes our entire attempt at contact as possibly the most dangerous thing our species has ever done. The AI noted one more possibility before it reached its final synthesis, and this one is strangely beautiful. It's called the transcension idea. What if advanced civilizations don't expand outward across the galaxy at all? What if, instead, they turn inward? As a civilization masters technology, it might find that the most valuable frontier isn't distant stars, but inner space, virtual worlds, miniaturized realms of computation running faster and deeper than anything in physical reality. Why spend thousands of years crawling between stars when you could build an entire universe inside a machine the size of a coin? Under this view, we don't see advanced aliens spreading across the sky, because that's not what advanced life does. It shrinks, it quiets, it disappears into realities of its own making, leaving the physical cosmos looking empty, even though it's full of minds that simply chose to go somewhere we can't follow. It's a gentler answer than the dark forest, but it still ends in the same silence. And here, after walking through every door, the AI arrived at the answer that ties them all together, the one that made the whole thing land like a punch to the gut. It's an idea called the Great Filter. And to understand it, you have to think about the entire journey from lifeless rock to galaxy-spanning civilization as a series of hurdles. First, dead chemistry has to become living cells. Then, simple cells have to become complex ones. Then complex cells have to organize into multicellular life. Then that life has to become intelligent. Then intelligence has to develop technology. Then that technology has to survive long enough to reach the stars. Every one of those steps is a filter, and somewhere along that chain there might be one barrier so difficult, so nearly impossible to cross, that almost nothing makes it through. That's the Great Filter. Somewhere between dead matter and a thriving interstellar civilization, there is a wall where the vast majority of everything gets stopped cold. And here's the question that left scientists speechless, the question that transforms this from an abstract puzzle into a personal warning. Where is that wall? Is it behind us, or is it ahead of us? Sit with that, because everything depends on the answer. If the Great Filter is behind us, if the hardest step was something we've already passed, then we are the miracle. Maybe the leap from non-life to life is the wall, and it almost never happens, and we are one of the rare lucky survivors. In that version, the silence is lonely but reassuring. It means we made it through the gauntlet, the road ahead is open, and the galaxy is ours to inherit because almost no one else even got this far. That's the good news scenario. But there's the other possibility, and it's the one that turns your blood cold. What if the Great Filter is not behind us? What if it's still ahead? What if the reason the universe is silent isn't that intelligent life is hard to create, but that intelligent life is almost impossible to keep alive? What if civilizations do rise again and again across the galaxy, and then reliably destroy themselves right around the stage we're at now? Right at the moment they gain the power to reshape their world and their weapons, before they gain the wisdom to survive it. Nuclear war, engineered plagues, climate collapse, technologies that outrun the maturity of the hands that hold them. Under this scenario, the silence is not an absence. It is a graveyard. It is the accumulated evidence of 1,000 civilizations that reached exactly this point, and then went dark, one after another, never making it to the stars. And we would be standing at the edge of that same cliff right now, wondering why it's so quiet, not realizing the quiet is the answer. This is why a leading philosopher once made an argument that sounds completely backwards until you understand it. He said that if we ever send probes to Mars or the moons of the outer planets and discover the fossils of alien life, even simple microbes, we should be terrified. Not delighted, terrified. Because if life turns out to be common, if it springs up easily all over the place, then the Great Filter almost certainly can't be at the early stages. It can't be that life is rare, because there it is, everywhere. Which means the filter, the wall that stops civilizations, must be somewhere later, somewhere ahead of us. And every additional sign of life we find would tighten the noose, would make it more and more likely that the barrier we haven't hit yet is a barrier no one survives. In that light, the emptiness we've always found so lonely becomes the most hopeful thing imaginable. A silent, sterile universe would mean the hard part is behind us. A universe full of dead alien life would mean our doom is still to come. It is one of the most mind-bending inversions in all of science. We spend our lives hoping we're not alone, and it turns out that being alone might be the only thing that saves us. So, when you strip it all down, what was the answer that left scientists speechless? It wasn't a single tidy solution. It was the realization that the silence itself is data. The quiet sky is not empty of meaning. It is screaming a warning, if only we know how to listen. It's telling us that something out there stops civilizations from reaching us, and that we do not yet know whether that something is a challenge we've already conquered or a catastrophe still waiting in our path. The Fermi Paradox isn't really a question about aliens at all. In the end, it's a mirror. When we ask why no one has contacted us, we're really asking a question about ourselves. Are we the rare survivors who made it through the fire, destined to inherit an empty galaxy? Or are we just the next in a long line of promising species about to walk off the same cliff that swallowed everyone before us? The universe hasn't answered yet, but the terrifying truth is that the answer might depend less on what's out there and more on what we choose to do down here in the next 100 years, as we hold in our hands the same powers that may have destroyed every civilization that ever tried to speak. That's the weight of it. We are living through the exact moment that decides which side of the filter we fall on. Every choice we make about our weapons, our technology, our planet, and how we treat the fragile intelligence we've been gifted is a vote on whether the silence out there becomes our future too. Maybe the reason no one has ever contacted Earth is simply that we are early, one of the first minds to open our eyes in a young universe, and the great conversation hasn't begun yet. Maybe it's that everyone learned to stay hidden in the dark forest, and our shouting is a mistake we'll come to regret. Or maybe, just maybe, the silence is the sound of a warning we still have time to heed. The cosmos handed us a question 70 years ago, and we've been chasing it ever since. Now, for the first time, we have tools that can help us reason through it with brutal clarity, and the conclusion they keep circling back to is the same. We are not just searching for our neighbors, we are auditioning for a future that most civilizations may never reach. Whether we make it is still unwritten, and that, more than any signal from a distant star, is the thought that should keep every one of us awake tonight. If this rewired the way you look at the night sky, do me a favor and subscribe. Because next time we're going even deeper into the questions that sit right at the edge of what we're allowed to know. The universe is trying to tell us something. The only question left is whether we're brave enough to hear it.